Okay, so today we're going to look at several basic functions and their graphs and the domain and their range. Ultimately, we're going to want to graph really complex looking functions, something like that. And we want to be able to do that by just looking at it and applying a few tricks. But in order to do that, we need some basic graphs as a kind of library of functions, library of graphs that we know all about. And then we can build something like that. So we're just going to run through several of them. Some I know we've seen before, so we don't really need to spend time on. First off, the basic quadratic. F of x equals x squared. We all know what the graph looks like. It's just the parabola. But now that it's a function, we care about the domain and the range. The domain we know we have done before. It's all real numbers. The range is what we haven't worried about yet. We said we would care about the range when we looked at the graphs. And now looking at the graphs, we can find it. The range of this one, well, the range is all the y values you get out. So if we start down here, you don't get any of these y values. The first y value you get is at 0, and then everything above that. So my range will be the set of all y's such that y is greater than or equal to 0. The next function we can look at, f of x equals x cubed. And as far as graphing it goes, if nothing else, plug in points and see what you get. If you plug in 0, you get 0 cubed, which is 0. So we get the point 0, 0. If you plug in 1, you get 1 cubed, which is 1. If you plug in 2, you get 2 cubed, which is 2 times 2 times 2, 8. And we can see on this side of the axis, it kind of curves up like this and gets bigger and bigger and bigger. Now look at some x's to the left of the 0. If you plug in -1, -1 cubed is -1 times -1 times -1. 3 negatives stays negative, so it's -1 down here. If you plug in -2, -2 times -2 times -2, again, 3 negatives, so it stays negative, and it's down here. And now we can see the graph, and it kind of looks like that. As some of my students have said in the past, it's like an elongated S. But as far as it goes, once we have the graph, we care about the domain and the range. The domain is all the x's you can plug in, and it's pretty obvious. You can plug in any x you want, and it gets mapped somewhere. So the domain will be all real numbers. For the range is all the y's you get out, and again, do what we did up there. All of these y's will get touched, because that goes down forever. And as you keep coming up, every y gets touched, and all the y's up there will get touched, because this goes on forever. So the range will be all real numbers. Those are two really basic ones. So now we'll look at a few others. Let's see. F of x equals square root of x. If we think about the graph, well, let's see. If I plug in 0, I get the square root of 0, which is 0. If I plug in 1, I get the square root of 1, which is 1. If you plug in 4, you get the square root of 4, which is 2. So maybe over here. If you jump all the way to 9, you get the square root of 9, which is 3. And we can see here, it's getting bigger, but not too quickly. It's kind of curved off to the side. If you plug in x's over here to the left of the 0, -1. Well, the square root of -1, it's odd. We've covered that before. But when we talk about graphing, we only care about graphing real numbers. So that doesn't work. So, well, I guess that's it for my graph. So we have the domain and the range. The domain, what x's get plugged in? And again, we have actually already done this one earlier in the semester. None of these x's get graphed, because we can't take the square root of a negative. The first x that gets graphed is 0, and then everything beyond that. So the domain is a set of all x's such that x is greater than or equal to 0. As far as the range goes, well, let's see. None of these y's get touched. The first y that gets touched is 0, and then all of these up here will get touched. It looks like this stays flat, but it does keep getting bigger and bigger and bigger and bigger over time. So ultimately, all of these y's will get touched. So the range will be the set of all y's such that y is greater than or equal to 0. There is actually a little trick to this. If you look at this, and that's the square root, which is related to the square graph looks like this. The square root graph looks like that. Well, they're pretty similar. Essentially, if you take this graph and turn it on its side, you get that graph right there. Yes, the bottom half is missing. But that's because, well, if I didn't remove the bottom half, this wouldn't pass the vertical line test and it wouldn't be a function anymore. So we get rid of the bottom half. This is what's called the principal square root or the positive square root. But essentially it's this graph turned on its side. So now, since we know that one, we can do f of x equals the cube root of x. And now again, if you use a little bit of intuition, if the square root graph is essentially the square turned on its side, well, it would be logical the cube root graph is like the cube graph, only turned on its side. And as it turns out, that's exactly what it looks like. The cube roots of positive numbers like 1 and 8 are positive, 1 and 2 respectively. The cube roots of negatives like negative 1 and negative 8 are negative. And we get that graph right there. Again, the elongated s, the cube graph, turned on its side. But just like all the other ones, we care about the domain of f and the range of f. The domain is all the x's that get plugged in, but again, every single x we can take the cube root of, so this will be all real numbers. The range, that's all the y's that get touched. And again, it may not look like it here, but this graph does get smaller and smaller forever, and bigger forever. So all these y's get touched, and all those y's get touched. And the range is all real numbers. So now I guess we have the square graph and the square root graph, the cube graph and the cube root graph, their domains and their ranges. Now there's like maybe one more we really care about. F of x equals the absolute value of x. Here again, if you're not sure what the graph looks like, if you've never seen it before, plug in x values and see what you get. If you plug in x equal to 0, you get the absolute value of 0, which is 0. If you plug in 1, you get the absolute value of 1, which is 1. If you plug in 2, you get the absolute value of 2, which is 2. And we can see pretty clearly this will just go up like that. It's at a 45-degree angle. If we look at the negatives, if you plug in negative 1, the absolute value of negative 1 is positive 1. So we'll get this point. If you plug in negative 2, the absolute value of negative 2 is positive 2. And again, we'll get a line segment looking like that, a ray. And there's the graph of the absolute value. Very similar to the quadratic graph, same basic shape, but this one comes to a corner, a point. But just like before, once we know our function and our graph, we care about the domain and the range. So the domain, well, that's all the x's we plug in. And again, no matter what x is, you can always take its absolute value. So the domain is all real numbers. The range, well, none of these y's get touched. The first y that gets touched is at 0, and then all those y's beyond there get touched. So the range will be just like the quadratic, the square graph, the set of all y's such that y is greater than or equal to 0. And there we go. Now we have several basic functions: the square graph, the square root graph, the cube graph, the cube root graph, the absolute value graph. Just basic functions that we understand their graphs, their domains, and their ranges. And then in my next lecture, we'll look at different tricks to graph more complex quadratics and cubics and things like that.